accuracy tells us how close we are to a measured value or to an accepted value. And these are just some definitions. Precision tells us how close a series of measurements are to one another. Another way to use the word precise is also if I measure something like 4.156, that's going to be a more precise measurement than if I say 4.1. So the further you go past the decimal, that's considered a more precise measurement. But when you have several measurements or several trials, if all of the measurements are close to one another, that is also considered precise. So let's look at this as looking at a dartboard. This represents low accuracy because accuracy would be the bullseye in the middle. So it's low accuracy because they're not very accurate, but they have high precision because they're all close to one another. Here we have a dartboard that shows us high accuracy because they're all kind of close to the middle, but it shows us low precision because the darts are not close to one another. And our last dartboard shows us high accuracy and high precision. They're all on the bullseye and they're all close to one another. Now, this is what I'd like you to do. Pause the video. I want you to draw a target that represents low accuracy and low precision. And then once you're finished drawing that, go ahead and resume the video. All right, so after you've drawn that, we'll actually check this in class tomorrow. So let's go ahead and talk about one more item. We have error. When we're doing a lab, a scientific lab, and we're measuring things and collecting data, we have error. And so error is the difference between an experimental value, what you get in your science lab, and the accepted value. So how you calculate that is you take the experimental value minus the accepted value, and that gives you what type of error you have. Then we also calculate percent error. This takes all of the error possible in your lab and divides the accepted value by it, multiplies it by 10 to give you a percentage of the accepted value and a percent error. Now, percent error is telling you how wrong you were in the lab. So it's not something super fun, but we do have to calculate percent error when we're doing labs in chemistry to see how far off we were. Now let's go ahead and look at some practice with this. Okay, guys, so let's look at an example of this. If we know that the density of calcium is 1.54 grams per centimeters cubed, and you're figuring out and calculating the density for a lab, let's look. I've already made up some trials for you, and so let's pretend that you did trial 1, 2, and 3, and those are the numbers that you came up with when you were calculating the density. So let's go ahead and calculate the error for trials 1, 2, and 3 over here at the bottom. For trial 1, to calculate the error, you take the experimental value, which is what you came up with, 1.3 grams per centimeters cubed, minus the accepted value, grams per centimeters cubed, and that's going to give you a negative 0.01 grams per centimeters cubed. Well, and you know what? You don't even have to really put the units with percent error, with error, okay? Now, let's go ahead and look at number 2. You had an experimental value of 1.52 grams per centimeters cubed minus the accepted value. So that's going to give you a negative 0.02 in error. Now, this negative is because you're below the accepted value. Let's see what happens when you're above the accepted value. 1.55 minus 1.54 grams per centimeters cubed equals plus 0.01. Okay? So this is a very precise trial and an accurate trial. You're actually pretty close to the original accepted value, and all of your measurements are close together. So that was a really good trial. Now, let's look at percent error. Okay? Percent error you have to do for each trial that you did. And so for trial 1, your percent error is going to be the error you had, so negative 0.01, divided by the accepted value, 1.54, and then you multiply those by 100. So initially, when you do 0.01 divided by 1.54, I don't know if you hear my calculator going, I'm having to calculate as we do this, you're going to get 0.0065, and then we have to multiply that by 100. Once we multiply it by 100, that gives us a percentage of 0.6 That means that was our percent error. That's really good, actually. And then you could do this with each trial, but I just wanted to show you one. And now let's look at one last slide. Here is a data table from student A, B, and C when they were doing a science lab. I would like you to answer these 3 questions, so pause the video, answer them on your paper, and then resume the video once you're ready for the answers. All right, check your answers, and then let me know if you have any questions. Make sure you write them down. And let's go ahead and finish up with a summary today. For our summarizing activity today, I would like you to do a tweet summary. Pretend like you're going to tweet about today's video, so it has to be in the same amount of characters as you would a regular Twitter account. So I'd like you to tweet a status update about our video today, and I'll see you in class.